Welcome to Math on Ice. Finding nth root of a complex number. So I'll consider a complex number z and I'm going to find the nth root for it. Nth root is nothing but raising to the power 1 by n. Okay, let z be a complex number. To find z power 1 by n. Okay, if for example, if you take 2 here, second root of complex number is root over z. Okay, and if I take 9 here, ninth root of complex number is I'm having any complex number 3 plus 2y, the whole power 1 by 9. This is called as ninth root of the complex number. Okay, you would have studied about the finding nth root of unity. Nth root of unity, in that case, you will have 1 power 1 by n. Okay, now unity to the power 1 by n. Now here I am giving you the general proof for any complex number, nth root for any complex number. So for that I have considered a complex number z. We need to find what is z power 1 by n. Now I'll consider omega is equal to z power 1 by n. What is actually z? Z is a plus ib, or it can be written as z is equal to r into e to the power I theta, where e power I theta is cos theta plus I sin theta. So instead of writing z, I'm going to replace it as r cos theta plus I r sin theta. So here I'll have r cos theta plus I r sin theta, the whole power 1 by n. Also we know that cos and sin are having period 2 pi, right? So after the 2 pi interval, the values are repeated again. So this is eventually r, instead of cos theta, the same value is applicable for cos of theta plus 2 pi k, where k is any integer entry. And for this sin theta, I'm replacing it as IR sin of theta plus 2 pi k, the whole power 1 by n is there, right? And then I'm just taking out r power 1 by n outside. So here also I have r, here also I have r. So I'm taking it out, r power 1 by n. What is left over? Cos of theta plus 2 pi k plus I sin of theta plus 2 pi k, the whole power 1 by n. We need to know for what values of k, this equation is valid. We also know a theorem called De Moivre's theorem. What does it say? De Moivre's theorem. If you take cos theta plus I sin theta, the whole power n, which is actually equal to cos n theta plus I sin n theta. You can bring that n to the power to angle. Okay, the power is being transferred to angle here. This is called as De Moivre's theorem. Now in the power we are having 1 by n. So this is equal to r power 1 by n outside, and this will be cos of theta plus 2 pi k divided by n plus I sin of theta plus 2 pi k divided by n, where k can take values from 0, 1, 2, so on till n minus 1, right? Totally k can take n values. 0, starting from 0 to n minus 1, k can vary from 0 to n minus 1, so it can take n entries. This is the omega is equal to r power 1 by n cos theta plus 2 pi k by n plus I sin theta plus 2 pi k by n. This is called nth root of a complex number. Got it? Now, in the next lecture, I'll solve some problems on the topic finding nth root of a complex number. Thank you.